Welcome to this episode of the Distributed Data Show. I'm Amanda, developer advocate here at DataStax, and this is my coworker Cedrick, all the way from Paris. And this is our first episode together, and so happy that you're joining me.
Yeah, I'm so happy to be here in Orlando, Florida. Let's talk about Timeseries.
Yes.
From DataStax, this is the Distributed Data Show.
So what we're here to talk about today is all about Timeseries. So Cedrick, along with many of his other duties as developer advocate, one of the busiest developer advocates on our team, he's been working a lot with our customers with different Timeseries use cases and applications. So can you tell us a little bit about just what Timeseries is? We hear a lot about it, but let's talk a little bit more about the real.
Yeah, sure. So simply put, Timeseries is a sequence of events, numerical data, always the same phenomenon that you record per time.
Okay.
And that's it.
Okay.
Simple.
Okay. So maybe something like weather over time, or
Sure.
Okay.
Weather, sensors,
right.
anything related to natural phenomena,
Okay.
right? Plant growing,
Okay.
temperatures, winds,
Okay.
all what you say.
Okay. So basically, it has a time element. It's a time series
It is.
use case. Okay. So we don't know about what Timeseries is, but why would you use it with Apache Cassandra?
Oh, that's a good question. So, when you are at the booth and somebody come to you and ask about Apache Cassandra,
Right.
how do you explain that NoSQL database in, let's say, 1 minute?
Ah.
I do say, okay, Apache Cassandra is a distributed database with multiple nodes. Data is distributed on the node, data is also replicated, but simply put, data is distributed. And on each node, you can have 1 terabyte of data and something like 3,000 transactions per second. And if you need more capacity or more throughput, then you just add node. And in Timeseries, what you really have is a lot of throughput. You get a lot of data coming from everywhere.
Right.
And you have to be able to absorb this stream in real time and fast. And Cassandra is well known to write fast data because you will write data first in memory and only then crush the data on disk. So for Cassandra, 10,000 writes per second is just normal.
And that makes a lot of sense when we're thinking about, like, again, it's so easy to think about IoT use cases with sensors. Right? There's
Sure.
going to be many writes from many sensors. And so the fact that Cassandra has that amazing write throughput seems like the perfect fit from what you're saying.
Yes, exactly.
Yeah.
IoT is one of the most common use cases we met right now, of course. IoT, logging,
Okay.
all this kind of stuff.
Right. Okay, so we know about Cassandra and using it as, the perfect use case for Timeseries, and we know about the write throughput and how amazing Cassandra is at writes, but we know that sometimes you have to do certain things if you want to have that good read performance as well. It's all about data modeling, right? So let's talk a little bit about data modeling for Timeseries.
Yeah, sure. As all the use case with Cassandra, everything is about data modeling.
Right.
So you have to build your tables, your data model based on your queries. And when you look at Timeseries, there are multiple queries you can do.
Right.
You would like to chart a graph, see the evolution of your data around the time, but you also would like maybe to aggregate data per 1 minute, 5 minutes a day.
Right.
So with Cassandra, first you have to create some tables and partition key based on the source of the data. Like that, if you have multiple sensors, load will be distributed among multiple nodes. But at a point in time, when you get too much throughput, then all the data going to one node is just too much for the node.
Right. A
And
hotspot.
It's a hotspot, exactly. So you need to split your partition key with some time element.
Okay.
This is what we call bucketing.
Oh, okay.
And that way, data will start to flow all around the cluster. And there is no more that hotkey that could fix all the issues. So you have your data properly and evenly distributed around the cluster now. What about read? What about the steps?
Right.
Seconds, minutes?
Well, you mentioned aggregations as well.
Yes.
So how are you going to be able to do aggregations on Cassandra? We know sometimes those two words don't always really go together, right?
Not at all, actually.
Right.
Yeah. There is no magic here. This is when you need to insert data, then you will have multiple tables. one
Okay.
tables per aggregation step.
Okay.
And
That's
actually,
a great strategy.
yeah, when the data came, you will write into multiple tables at the same time.
Okay.
Of course, you can also write at a single tables and have some batches like Spark or any tools that will aggregate on vacations data for you. But most of the time, it's just the source that writing multiple tables.
That makes sense.
Yeah.
Yeah, and it seems like a good strategy.
Yeah.
Especially always one query per one table.
Yes. Yeah, exactly. And those data don't have the same time to live. Maybe if you want to have a 1 second step, you will keep the data for 30 days or maybe 7 days. It's fine just to graph
That
your
makes sense.
series about day to day.
Right.
But now, if your step is 7 days and you want some data over a year, then it's not the same TTL. So having your data distributed by table is a good way to ensure that TTL.
That makes sense. And also like what you were saying about aggregations, right? You can aggregate your data maybe with something like Apache Spark, and then you can actually save that data back into Cassandra after it's already been aggregated.
Exactly. Yeah. And some tools, open source tools, already leverage on Cassandra to build some ready-to-go time series database, like KerosDB does.
Okay.
So it's all about aggregating. So we all know how to data modeling into tables, and they choose some model to aggregate per period of time, and it does that for you. But it's still aggregating
Right.
for you on top of Apache Cassandra.
On top, right? Makes sense. Okay, so we've talked about aggregations and we have some good strategies around that. So I think that's great. But again, when I'm thinking about time series data and I'm thinking about IoT data, I'm thinking the volume of data. There's going to be lots and lots of data. So what are some strategies that you can do to kind of help with that, especially when using Apache Cassandra?
Yes, sure. Volume is a big thing.
Right.
I already talked about the bucketing thing to evenly distribute the data among the cluster, just to avoid wide partitions or hotkeys. But still, with time, you will get a lot of data.
Right.
So, to be able to handle that kind of data, first idea would be to compress the data, because
Okay.
you always access the data the same way. They are still numerical. They are good some compression
Okay,
ratio like LZ4 for that.
That makes sense.
But even when, at a point of time, your use case with time series change. For instance, for the first 30 days, you can just want to graph and troubleshoot the phenomena you are recording.
Right.
But then you would like to switch to analytics queries.
Right.
Dimension analysis, some kind of things. And now the good way to store the data would be column-oriented.
Okay.
And on DataStax Enterprise product, we have Spark
Right.
that can just take the data and move it to DSCFS, which is an implementation of HDFS,
Right.
storing data as Spark file,
Okay.
which makes very sense to do some analytical data.
Right. Absolutely.
So good practice is to keep maybe 30 days of data in Cassandra, or
Okay.
enough data to be able to perform your graph and real-time queries.
Right.
But at the point of time, just move the data, copy the data to a cold storage location.
Right. That makes sense. So you have your hot data, your cold data, and you can do your aggregation work continuously on that cold data as well.
Sure.
Right. And then move that in also with your charts and graphs. Great. Well, thank you, Cedric. I think we learned a lot about time series today, and I really loved filming this episode with you.
It's nice.
It was very nice. Thank you.
See you
Tune
next
in
time.
next time.